Hi, I've got a speaker box sitting on the floor, and some of you may be a little bit confused as to why we're looking at a speaker box, judging by the title of this video. All of that will be made clear in just a moment. And I'm also going to explain my plan that I've got with this speaker box right after this. Greetings, the Astro 30 here yet again, and as you know by the title of this video, we're going to be looking at that ElectroIndia power amplifier again, and this time it's part 3. In this part I'm hoping to actually mount the thing to a heatsink at least and finish up the construction of it. However, back to why we're looking at this speaker box. This is one of these party speakers. They come as a set, but I've only got the one. I think it's the left hand channel. They say it's 100 watt, but yeah, or whatever. And it's a professional party speaker system. Ooh. They were actually pretty crap. They had a crap little 25 watt per channel power amplifier that ran off about 12-15 volts, I think it was. I used to have one a few years ago, and the power amplifier had died in it. I had the actual speaker that had the amplifier in it. I've actually now got the second speaker that the amplifier goes with, and don't have the amplifier. Anyway, I've been to the tip shop, or the recovery shop we call it over here, and paid $22 for it. And there's a little frequency versus power and sound pressure level graph there, which is pretty much meaningless. It's got a little 6.5 inch, I believe that is, driver in it. 2 tweeters, so these would be wide, I assume, in parallel. On the back of it, it's got a little speaker connector for the connection to the amplifier, but I can't see how this is mounted. There's no screws, so I can't take it out. So I might have to pop that out from the inside. But my plan for this piece of crap, cheap Chinese speaker is I'm going to build the ElectroIndia amplifier into that. Now, I had a few ideas of how I was going to do it, but I think I've finally come up with the solution. Now, I'm going to take all these drivers out in a minute so I can have an inspection of the inside of the box so I know what I'm up against. This panel does come off, and I really want to get rid of that text, because what I'm planning to do is the speaker is basically going to spend the rest of its life living like this on its side, and I'm going to put some feet on the bottom of it as well. But the way I thought about mounting it is there's going to be a preamp in it, and the preamp is going to sit on top of here. So the lighting is pretty piss poor down here, so why don't we pop this up on the desk so I've got a better viewing angle. That's a bit better. And the amplifier is going to be called the Joe Mama 69.
Nice.
Right, now all jokes aside, I'm going to pull the screws out of this speaker grill so I can get to the driver behind it, and then take the driver out. Now, I'm probably going to replace these screws because they are a bit rusty. There's the grill off. I have to measure that speaker. It looks a little bit bigger than 6.5 inch, maybe 8 inch. It's hard to tell. Are these the same screw? They're a little bit shorter. Okay, the driver seems to be staying there. Let's see if we can get this to come out. There we go. Ah, you bastards. That makes things more difficult. They've hard soldered the damn connections to the speaker instead of using connector plugs. So that's going to make this a little bit more awkward. That's not how I plan to do this. But we've got main wires from the socket connected to the driver, and then we've got 2 wires running off to the tweeters above. So, but inside the box, there's not even any bracing. There's a little bit of bracing up there. There's some there, so when I actually cut the hole for the preamp in, well, that side, I'm going to have to do it somewhere towards the middle to overcome those bracings. But look at the quality of the build of this. It's pretty crap. I don't know what type of glue they're using, but yeah. Ew. Look at the amount of bugs that decided to crawl in through the hole and commit suicide. Probably through that porthole. Now, this is obviously a ported box, and so it's going to have bass reflex to it, but that's alright. Generally speaking, the build quality of this is pretty well rubbish, and it is chipboard, and it looks like it's, well, I want to say 12mm chipboard. That's why it's so light. It only weighs about 10 kilo. Alright, so now I'm going to mount the bass driver back into the box because I don't need it out anymore. I don't know how I'm going to overcome this, but it is what it is. But I wanted to look at this speaker to see what it is, and apparently it's a 6 ohm. So it says 6 ohm there, but I am not 100% sure what wattage it is because it's not marked. I doubt it's 100 watt, but it is a substantial magnet, but it's 6 ohm. I don't want to power that amplifier into a 6 ohm load, so I might have to replace the driver. Okay, that's back in. Yeah, I'm not really happy about the way it's connected, so let's take these tweeters out because I didn't see a crossover cap in there at all. Okay, yeah, I think these screws need to be replaced. They're all a bit rusty. These tweeters are easily replaceable. Oh, wow. There's our crossover. Badly done. They've got, it's not even soldered. They've got a resistor here, which I can't read its value, I'll have to measure it. Then going through in series with a capacitor, not sure what value of capacitance that is, going into the positive of the tweeter. That's probably a 4.7 microfarad capacitor or something, non-polarized I hope. Second one. You gotta be kidding me. It's a dummy. It's not even a tweeter. You bastards. That is the most crappiest. Now, I've forgotten when I pulled the other party speaker apart what was actually inside of it, but I certainly don't remember that. What a waste of engineering. Why would you make the dome without the innards in it? I mean, yeah, this is obviously probably part of the real tweeter, where the guts of it are put in, like the little piezo diaphragm in there, and then put the leads on. And of course, before I move on, it wouldn't be complete without a diagram of how they've wired the speaker. Now, here's your positive, your negative inputs. There's the main bass driver, the 6 ohm one. There's our 5R1, it's about a 2 watt resistor I reckon, in series with this 2.5 microfarad going into the tweeter. The positive of each speaker is there and the negative is there, respectively. I didn't mark that on the diagram for clarity. Anyhow, you could, for all intents and purposes, as badly drawn as this is, because I'm working sideways and I'm not Mr. Squiggle, you could actually add another tweeter in parallel with the first one, and it would still work just as fine, but you may have to increase this current limiting resistor, which is what this is for, is to limit the current, as well as only pass the highs through to the piezo tweeter, because any lower than about a kilohertz, I believe it is, maybe 3 kilohertz, don't quote me on that, but any lower than a certain range of frequency and it will destroy the piezo diaphragm inside the tweeter, and the tweeter will be no longer useful. So anyway, enough talking about this sodding piece of crap speaker box. We are going to move on to the power amp.
Sick, mate, sick, subwoofer. Fully sick, bro.
I've got two powerful 6 amp mains transformers. They're 0 volt to 30 over two 15 volt windings. So I'm going to have to wire the 15 volt rail on one side of the transformer to the 0 on the other, and take the 15 volt off here and the 0 there to make the 30, and then these two are then going to be wired in series with each other in phase to give me 60 volts AC, which will give me roughly 84 volt DC after rectification from the
Full bridge rectifier.
Thanks Medi, and yeah, 42 volt plus minus, and they're going to be attached on the left hand side edge of the inside of that speaker box, just behind the speaker driver, along with the power supply, which will be the bottom edge. So those two transformers are going to give me a massive 12 amps of current capability, which is way too much. Well, it's not too much, but it's overkill. And I'm going to finalise assembly for the moment with these header connectors. This is a three-way header, which is JCar Catalog HM3443. There's the plug that goes with it, which is a HM3433. I've also got a 2-pin header. This is for the speaker socket, the other one's for the power rails. This is a HM3442, and its accompanying plug is a HM3432. So they're just the correct pitch and the correct lead spacing size to fit in the hole, and it will clear my screw just nicely. So that's all well and good. So I'm going to start by soldering them onto the board. Okay, these should be a lot easier to deal with than the smaller ones that I normally use, with the wiring of the plug, I mean. And yes, I use anything to support something when I'm soldering it. So I'll start by soldering the center pin. Just lightly tack it so in case I have to move it. No, it's perfectly fine. Please let me know if you find my videos a little bit too long. I will try and make a better effort to make them shorter in the future. Like if you want me to cut out banter or other rubbish that's not necessary to the context of the video, that turned out perfectly fine. Just solder the speaker one in now. Then let me know in the comments below and I will address that. Some people like it, some people don't. So just finish this off. Okay, but I just want to bring up one little point. Now this is what might go wrong or can go wrong sometimes when dealing with high-powered power amplifiers like this. A mate of mine from Patreon has assembled this board and he tested it over the weekend, and well, I'm going to put up the pictures. I've got his permission to do that. This is what the result of powering it up the first time did. It literally went off with a complete and utter bang. Now, as we can see from the photos here, that most of the output stage resistors have completely killed themselves. And judging by the photographs that are on the screen right now, this looks like this happened as a result of a direct short circuit, probably most likely on the output. Could have been that the output stage IRF P260N transistors, the ones that go up here, may have been in contact with the heatsink, because he did drill 2 holes like I have here, and that's on the ground plane, so that's bringing the 0 volt rail down to the same potential as the heatsink if it's so in contact with it or making electrical contact. And so if the MOSFETs were in contact with the same heatsink and the insulation material was either cracked or broken somehow, so it made a short circuit, especially on, you know, the center pin, yeah, that could be disastrous. Also, the other thing is he was running it at 66 plus minus volts. Now these little BC 546s and 556s respectively, their maximum collector to emitter voltage is 65 volts, so you are actually pushing those transistors to their limit. Just keep that in mind. So a voltage of, what's that, 132 volts DC might be a little bit too high for this module. And also having a short circuit on anything that's close to the output or the output itself, that is the disastrous results that can happen. The whole thing goes up in a puff of smoke. So I guess that long-winded explanation was to make it known that when you're testing a high-powered amplifier like this, it's best and almost paramount to test it on a bench top power supply that's capable of current limiting, so that you can wind the voltage up slowly, and if you see any unusual current spike or the voltage stops increasing, you know that there is a short circuit, and you can continue not to test it and find out what the problem is and correct it. It's also another good reason why this module should have fuse protection on the power supply lines for a direct short on the output like that, because left unchecked, these MOSFETs are capable of putting 200 volts DC between their drain and source pins quite happily, which would be an excessive amount of current going through those transistors. But I thought I'd just mention that before we move on. It makes the video a little bit longer unnecessarily, but I thought it was a valid point to bring up. So now we're going to move on to mounting this PCB on a heatsink as well as the output stage. JK really need to start sponsoring this channel. All this you see on the desk in front of me here is $117 worth, this being around about 43. So all throughout the thought process of this ElectroIndia 200 watt MOSFET power amplifier, I've changed my mind several times, and I'm going back to my original idea. I've got a HB5041 die-cast enclosure with flanges on either side, and it's 171 by 121 by 55 millimeters, which is just big enough to mount this power amplifier board and its transistors, and using the box as a heatsink. Now I want to have the wires come in and out of the enclosure, so I'm thinking about drilling 3 holes on top here. The board's going to be mounted at the top as well, and that's going to be for rubber grommets. One's going to be the speaker output, one's going to be the power input, and one's going to be the audio input, and I'm keeping them separated apart from each other rather than, you know, tied together. Alright, so there's the enclosure out of its plastic bag. Now I've got to get this top cover to come off. There we go. Now it looks like to me this is like nearly 3 millimeters thick, so we're talking about probably 8 gauge aluminium here, but there's a seal for the lid, which I'm not going to use because it can be used for waterproofing, because this is designed to mount outside. These, however, do have threads in the holes, as the dummy loads case did not, but these do, so that's brilliant. So everything is going to be mounted to the inside of the top here, and so I'm going to have to drill some holes. The first holes being, I'm going to drill the 2 mounting holes, so I've got some reference to work with. Now looking at this, we do have that to concern ourselves with, so I probably will mount the board down here, over here somewhere, just to give the transistor somewhere to mount to. Now with these little manufacturing marks, whatever they are, might cause an issue, it might not, but that's what I'm working with. So let me just get set up, and I'll mark out these 2 holes ready for drilling. This 3.2 millimeter drill bit must be blunt, because I was going for a good 2 minutes and it wasn't even getting through 2 millimeter thick aluminium, so I believe that one's blunt. I changed to a 3 and it drilled straight through, so, well, yeah. Penis! So that's what I've got so far. I've got 2 10 millimeter, I think they're steel, standoffs there. Their catalogue number HP0900, and they come as a pack of 8. I thought I had to buy a pack of 100, but no, they do have packs of 8, which is smick. So that means now the power amp will mount like that on those standoffs, and the transistors will be mounting from the copper side at right angles on this piece of aluminium, so they'll be bent at right angles and coming through the bottom of the board. So let me just screw this board in and kick the tripod for the 100th time today. The screwdriver is probably a bit big for this job, but what I want to do is first make sure I mean, these standoffs aren't actually tight yet, they're just only just sitting there with the screws on the other side to give me something to mount to. I just want to check that the fitment of this is not going to interfere with anything. Once I get that screw to do up. My holes are probably slightly off, but not that much. It should clear it just fine. There we go there. See, perfect. So that's a perfect fit. Now, is this going to be a adequate enough heatsink? Probably not, even when it's connected to the box. If it proves to get too hot, I will mount another heatsink on the, well, a heatsink on this side of the case. Right, so now I need to work out my transistors. And here they are. I probably should check that these aren't shorted. In fact, I might do that. Alright, now I believe it goes gate, drain, source. So, from left to right, so I'll just do that. I could be completely wrong. Probably am. Maybe it's drain, source, gate. Okay, well, I found a diode there. MOSFETs are kind of difficult to test. Nope, it's definitely gate, drain, source. I'm probably measuring it wrong, but all I'm testing it for is short circuits. That's all I care about. I just don't want it shorted across any of the pins wherever I've done with my negative lead. Okay. It's fine. This is the second one. I've already tested the first. We've got some resistance there, so that's fine. There's resistance there, 10 mega ohms or something. So yeah, it looks like those MOSFETs are perfectly fine, so I don't have to worry about them being short-circuited. Back to what I was doing. So what I'm going to do is I'm going to bend them up at right angles, close to the pins, where it goes into the thick part. I just hope there's enough lead length here. I'll soon find out, because once I've bent it I can't really go back. So that's one, as messy as that is. I'll see if it fits in the board properly. Right, well, it should if I unscrew it now. I'll just make sure it all fits in there nicely. Okay, so I need to put that in this one here. If I can so get it in the holes, like so. Okay. I might have just enough lead length, so I'll just bend the other one. It doesn't give me quite enough lead length. I probably need shorter standoffs, but this should be fine for what I want it for. So, I mean, I'm not going to bore you with all the construction details here. I'm just giving you bits and pieces across the way, because let's face it, I just want to get this done and get up to the testing phase. Now, they're both the same transistor, obviously, so it does not matter which holes you put them in. So the MOSFETs are in, so now I can adjust their spacing and fix them, straighten them up if I need to. Right, so I've got just enough lead length sticking out the top of the board here to solder to, and it's double-sided board, so that makes it a lot easier. I'll do the MJ E350 and 340 in a minute. I'm just going to first get these output transistors soldered in. Alright, I need to get this done as quick as possible because I've got somewhere else to be shortly. But we're getting ever closer to getting to the testing stage, which I'm very happy about, because this has been sitting around for about 2 months, not doing anything. It's one, because I can always take the board back out and touch the solder joints up from the other side if I need to. Now, I hope this one doesn't go off with a bang like my mates did. because that'll be very disappointing and quite a loss of money. And I have got seal washers for this, so I haven't forgotten about that stage. Right, that's the MOSFET soldered in for the first and last time. So now I can take, well, I might actually mark my transistor center point of the holes where I need to drill them, so I can get that done as well. My fly is open for some reason. Not that anyone needed to know that. So I'll take the board back out, because I've still got to drill 3 holes in here for the grommets, for the wiring, which is alright. But I'll just take this screw out, inspect the solder joints underneath. Yeah, they could do with touching up. As you can see, it hasn't quite penetrated all the way through, which is perfectly fine. Done. So you want to make sure that these are soldered correctly and thoroughly, because if these aren't jointed correctly, you can end up with issues with probably DC on the output, because, well, the transistor's not conducting correctly. So, and whilst I'm thinking of it, here are the seal washers for these transistors, the TO3Ps, and it's catalogue number HB1174. So that's all good. Now I can, well, fashion the MJE transistors in the same sort of vein and get them soldered in, mark my holes, and then drill them out. So I'll do that off camera. And a short time later, there we go, it now looks like a power amp with the output stage and drivers now soldered on. So this board, soldering wise, is complete apart from the wiring. I've marked all my holes on the panel there where I need to drill. So that's the next thing I'm going to do, is drill those 4 holes, and then I'll mark out the other 3, and then we'll proceed from there. Alright, done. So a stepper drill bit is paramount in doing this job. Now I'm using these rubber grommets. Now this is catalogue number HB0704. They're an inside diameter, I believe it is, of 9.5, overall of 12. Probably made the hole slightly too big, but that's alright. They fit in there just nicely. I think I've got like a 14mm hole or something. There we go. You might have to play with your rubber with your fingernail in order to get it to go in there. That's what she said. Okay, so now I can mount, I've tightened up these standoffs, but now I can mount this power amp for probably the last time. Now I have not worried too much about whether the ground plane is going to come into contact with the casing. It's not going to be grounded there anyway, so that is kind of irrelevant. The only thing I've got to do now is put the seal washers in and tighten the output stage, and then check that it's isolated from the case, because otherwise we're going to end up with a fireworks show. Alright, so that board is now in. Okay, so I'm working standing up and to the side of the camera here, which makes it awfully difficult. So I've got some, these are probably going to be too long. I've got some 10mm ones somewhere. There's my seal washers. Where have I put the 10mm ones? Here they are. I've got some HP0403. They should be enough to get through the transistor. And get a nut on the other side, which might be a good idea if I go find some 4 nuts. Alright, found them, and for some reason I bought more 10mm long screws for absolutely no reason. I already had some. Alright, whatever. So I need to open the TO3P seal washers so I can get 2 of them under each MOSFET here. Now these are greaseless mica washers. Well, they're not actually mica, they're silicon, and I've just lost some bushings. For sake. Alright, so now I'm going to have to pick them up. But they're greaseless washers, you don't need any heatsink transfer compound in order to use them. Check it out, it is now an output stage. Yay! It's all mounted in there. That washes a little squiff, but it should be alright. Next thing we need to do is just check that each transistor is isolated. Alright, with my multimeter set to continuity, and then I'm going to check, make sure that they're isolated. Indeed. Indeed, they're isolated. So now I'll just check the output of the speaker, make sure that's not short-circuited in any way, which it is not. Make sure the power supply rails are not shorted. They are not. So it's all looking good. When I test this, I'm going to test it on half the voltage. So I'll be using 15 0 volt 15 as the initial test, the way I've got the transformer configured now, before I introduce the second transformer. That will give me a chance to work out if the bias is going to adjust correctly, the DC offset is going to adjust correctly, and we're not drawing too much current, and the thing doesn't go up in smoke. So far, that's what I've got. It's a shame the steel washers are sort of like hanging up a bit, but it should be fine. I'm happy, ecstatically happy, and we're ready nearly for the testing phase, but what I have to do now is I have to do all the wiring, well, at least these two connectors. That one I'm not so worried about at the moment. But that'll be my next task, is to do the cabling, which I might do a little bit later because I've got to go out now. But yeah, it's coming on. I'm quite happy. Good morning. It's actually the next day. I didn't get around to doing the wiring last night because I was too tired. So I've just done it this morning. It's taken me about an hour just to do 3 sodding connectors. I don't know why. It just does. Got the power, the speaker with some hefty lead here connected. I've left the input disconnected during the preliminary test because I don't want any noise picked up by the input, because that can affect the current reading when you're trying to adjust the bias. So we'll leave that disconnected so there's no chance of noise getting in the circuit. And I've got little strain relief here near the grommets using cable ties just to stop it flapping about and pulling out, which shouldn't when it's actually mounted inside the speaker box. And yes, that is the reason for this case. It's going to be mounted inside that speaker box. That's what I'm doing. Okay, so now I'm ready for a preliminary test. I want to set it up to a power supply. I'm going to set it on, well, I'm going to use my 15 0 15 volt wiring on one transformer first, so I've got the lowest possible voltage that the circuit will still operate with, just to do initial power up test, just to make sure that everything's fine with the circuit. It's not going to, you know, go up in a fireball. Okay, here's my setup. Got a power cord connected to a terminal block which goes into my power transformer, going into the power supply where it's normally supposed to go. These wires are not going to be rated at the full current, just keep that in mind, but it'll do for testing now. I've got two 220 ohm resistors in series with each power supply rail, and no, these are not shorted. They're called safety resistors. What that means is if there's too much current being drawn by the circuit, these resistors will burn up and go open like a fuse. So if you see smoke coming off of these resistors, you know there's a problem. I've also got my multimeter connected across the positive 220 ohm resistor there to measure the voltage drop. And I'm looking for around about no more than 8 volt voltage on the meter there. If it's any more than 8 volt, if it's any more than 12 volt, I'm concerned. And if it's any more than like the supply voltage, which is around about 20 volt per rail, or at the supply voltage I should say, there is a definite problem. Okay, so I'm ready to plug it in, and I'm kind of nervous at this point because I don't know anything about this power amplifier. I've got the output lead disconnected as well, just in case it shorts on anything. Here we go. And we've got 0 power. Well, this terminal block was supposed to make it easier, you know, to power things without it not working. Take two, I've actually made sure that my screw connections on the terminal block are actually making contact with conductors and not insulation. Here we go. Seriously. I don't know why this is not working. It should. Okay, that power lead was junk. The live is open, so I've gone back to this way, which is not easy, but there we go, I got power now. I actually disconnected the amplifier's supply rails before I did this test. Right, I'll hook it up again and we'll try again. Okay, we're ready. I'm going to plug it in now, the amplifier's hooked back up. And I've only got 3.8 volt going across that resistor. So far, everything is hunky-dory. It says negative 3.8 volt because it's backwards. The connections are backwards. Preliminary touching this, I do not feel any heat coming off the resistors. The MOSFETs are getting slightly warm, they're not really hot to touch. So now I want to see if that bias pot does anything. When I turn it, does the voltage go up and down? Yes, it does. Look at that, nice. Goes down, goes up. Alright, I'll leave that back in the middle. We can do a quick calculation as to what current we're experiencing at that voltage using my favourite thing, Ohm's law. Okay, so we've got 3.93 volts, I'm going to say, so it's the voltage, whoops, the voltage now divided by the resistance, which is 220 ohm. We're looking at a current draw of roughly 17 mA. So to get 30 mA, I can multiply that by the resistance, and that means that the pot needs to be adjusted so you get 6.6 volt out of it. When it goes on the full supply voltage, it's going to have to be adjusted again, but for now I'm going to adjust this pot. I don't know if I can get that amount out of it. Well, it jumped up to 12 volt. That's close enough. That'll do for now. Nothing's hot. Nope, nothing's hot. Cool. Next, it would be a good idea to see if there's any DC on the output. Bugger all, about 50 millivolts. So let's see if the DC offset adjustment pot actually does anything. So I'll just turn this one. That's increasing. So going counterclockwise will increase that. Clockwise rotation, it's very fiddly. A multi-turn pot here would have been probably better, but I don't think I'm really going to get the DC offset that much better. Even the capacitance from the screwdriver is affecting the reading. Yeah, it's slightly lower. All that pot does is basically balance the input stage. Yeah, it's very touchy. I can't quite get it to 0. Yeah, well, that'll do. Right, so I now know it's safe to connect to a speaker without any problems. So yeah, that might be a bit awkward now, but I'll bring the speaker over under the desk and I'll connect it up and see what happens. I'm going to unplug it first. Just want to see if it makes a blurt test. If it passes the blurt test, then that's fine, and then I'll put it on some test equipment just to see what the output signal looks like. Alright, the speaker's connected. It's kind of in my way, but it'll do. So I'll power it back up and see if it makes any weird turn on transients. No. Okay. Let's see. There we go. It's working as an amplifier. Yay! Okay, so here's my setup. I've got the dummy load connected to the output wires. I've got a 10 mega ohm resistor 1 watt in series with the positive output. This is a poor man's times 10 probe. For a 1 mega ohm input impedance oscilloscope, which is what this is, you need a 9 mega ohm resistor in series to give it times 10, so I can't get a 9, so I've got a 10, so it's probably more like times 11 at this point. Got the signal generator hooked up and still set to around about 500 millivolts. I'm going to plug it in and see if anything goes off with a bang. It's the first time using this dummy load. Now I've also removed the safety resistors off of the positive and negative rails here because they're no longer needed. Yeah, so the bias adjustment may be slightly higher, but that's okay right now. Plug it in. And I do have a signal output. Nice. Right, so currently I'm getting 1.13 volt out, which would be more like 10 volt. Now, this has a maximum input of 50 volt peak to peak. So if I know it's 10 volt there now, I should, just to compare voltage measurements, move that to the other side. And yeah, it's peaking out at 13, so we've got an error voltage of about 200 millivolts or something there, so it's not that way out. So it'll give us a basic idea. So I'm going to wind the amplitude up. And now we're clipping there by the looks of things, and the amplitude is not increasing. So I'll back that off until it starts to decrease again, which is about there. So we're putting out roughly 21 volt peak to peak, which is to be expected. And I'll just do a heat test. They are getting mildly warm, so is the aluminium plate, but so far it's not too bad. So we'll say it's a maximum of 21 coming out. Well, we'll divide that by 2 equals that, multiplied by itself equals that, now divided by the resisted load, which is 8 ohm. Currently we're producing 13 watt. So at the full voltage of 30 volt AC, which is roughly 42 volt plus minus thereabouts, I expect to see double that in power. So it looks like this is going to get nowhere near the mythical 200 watts purported. Yeah, but everything is remaining stable thermally, nothing's getting overly hot. And the next thing to do would be to wire it up to the 30 volt transformer by bringing the second transformer in series with the first one and fix up all the wiring. Okay, there it is wired. I hope I've wired it in phase and correctly. This thin green wire is my center tap. It'll do for now. I forgot to get more green wire of the 7.5 amp range. Got it hooked up to a meter now, so both those transformers are in series. So now I'm going to see what happens when I plug it in. Absolutely nothing at the moment. Okay, with the multimeter actually set to auto ranging and not what it was on, I now have 63 volt coming out across the 2 transformers, so that's what it's supposed to be. It's a little bit higher, so I'll just lift one active off and connect it across the center tap, and I should have 30. 32, close enough. Alright, this is ready to connect up to the power supply. Okay, it's hooked up to the power supply now. I'll just plug it in. And the DC output is 88 volts. That's across both rails, so it's 44 plus minus volts there. Almost 90. Whoa! Don't know what happened there, but the voltage started to spike up to about 180 volts. I think it might be the meter lead connections, because when I unplugged it, it started to go up to 300 volt on its own. So I've left it plugged in now and I'm letting it stabilize. That was scary. Right, I've got it hooked up back to the amp. with the safety resistors reinstalled, the bias and DC offset pots have been set back to their center position. The input and output are disconnected, so all I've got to do now is apply power and look at the voltage drop across that positive 220 ohm resistor. 4.32 volts, thereabouts. So I can actually do my bias. Now, what did I say the voltage needed to be 30 mA? I think it was 6.6 volt or something. So I'll just adjust this bias pot. Thereabouts is good enough. Pot sort of went right back to where it was. I got the safety resistors removed, it's powered up. So the next thing to test is what the DC offset's doing without the safety resistors installed. This might be a little bit difficult. Input's disconnected anyway. So I want to disconnect the dummy load and plug the speaker back in, and I'll just measure across the output. Currently the meter says 66 millivolts, so let me find my screwdriver again. And I will adjust the DC offset pot. So that's about the best I can get the DC offset adjusted down to. We're looking at the 16, 17 millivolt range. Is it going to hurt the speakers? No, not really. But I can't... Well, okay, that's better. 2.1. I'm going to call it good. Alright, with the dummy load connected back up, let's plug it in and the signal generator. Of course, as soon as I move stuff around, I lose connection. There we go. I've got an output. So, we're currently on times 5. Okay, yep, we've got 1.1 volt or 11 odd volt coming out. I'll just wind the signal up. I can hear the transformer. Now, can I get that lower? Yes, I can. Alright, there's clipping. That's where the signal's good, and I'm getting 47.5 out of it. Let's turn that down. Yep, okay, so that is getting warm, and I could hear the transformers complaining, but okay. So 47.5 volt. There's a 47.5 thereabouts. It's not accurate. Divided by 2. Multiply that by itself. There is an easier way of doing this, but I'm not doing it. Equals that. Divided by the load. 70 watts. Thereabouts. It's quite capable of 80 watts, but it's still nowhere near the mythical 200 watt purported. But even 70 watts is pretty significant. So you could see the difference between using 15015 now versus 30 plus 030. It's not exactly double, it's actually more than that. But then again, it could be anything. I want to find out what the input sensitivity is of the amplifier now. What I'll do is I'll wind it up till it clips and wind it back, and then I'll kill the power, and then I can measure what's coming out of the oscillator. Okay, so I'm going to wind it up now. It's closer to 50 volt actually, so I can redo that calculation. I'll kill the power now, I'll measure, and there's our answer. We're looking at 2.5 volt peak to peak before clipping, easily enough. So yeah, about 2.5 volt peak to peak before clipping. Right, so our first calculation was 70 watts. Let's do it at, if it was like putting out 50 volt before clipping. 78 watts, close to 80 watts. So I'm going to call this a 75 watt amplifier at plus minus 44 volt, which is still significant to pickle any speaker driver. But yeah, it works. I'm quite happy. I'm not going to do much more else with it now, but there are a few things I would change. Number one, I would have the VBE multiplier in contact with the heatsink, because this currently is not in contact with the heatsink, so there's no way that that transistor can compensate and adjust the bias by lowering it when it gets hot. That's pretty much useless. I did think of a few ideas of how to make it in contact, but haven't done it. Secondly, I would change these pots, these trim pots, to multi-turn ones. 10 turn, multi-turn, 25 turn, whatever you want. Just so you can get a more steadier increase or decrease in the resistance and get the voltages smick. So last change I would put is actually include fuse protection on the board, at least on one of the rails, because yeah, what happens if there's an amplifier fault or a shorted MOSFET on the output there? It's just going to destroy the power supply. And one final change is I would make this board longer at the back, here, out of shot, so that the transistors can actually mount flat to the heatsink bracket with some rigidity, so that the actual board is in contact with something, so it can be mounted directly to a heatsink without too much trouble, because this was a pain in the ass to compensate for. Okay, and it wouldn't be complete without seeing what it sounds like. Sounds alright. Keep it down. Okay, try another track. That tweeter sounds like shit. But it is working. It's beautiful. Let's try another track. It's not getting hot. That's good. It's all Christmas crap. A phone's not a good source of audio. This is coming from the YouTube Studio Library, so I shouldn't have a copyright flag on it. Okay, I've had enough of listening to that. Alright, so I'll just unplug it now so it's not making any rude noises. There are no turn on or turn off transients, which is amazing. What do I think of this? Well, it works. It does work good. And I'm actually pleased with the results. It was well worth the wait, and you know, ordering stuff, waiting for it and stuff. I'm not really liking my transformer arrangement at the moment, but yeah, I might still order a toroidal later on. But for now, it gets the job done. So the next thing to do is to jam everything in that box. Yeah, and as I say, with those transformers, it's going to make it a little bit awkward, but it can be doable. So I hope you guys enjoyed that video and this series of videos that I've done on this. It's been a long time coming, but I'm very happy to say that mine didn't go up in a puff of smoke. So I reckon it was more likely in my mate's case that it was a shorted output transistor to the well, ground, because these are drilled through the ground plane, so that will bring the 0 volt to the same potential here, which then if these transistors touch that same potential, well, it's basically shorting one of the supply rails out. Anyway, that being said, I'm the Astro 30, and if you found this video informative or you liked it, remember to drop a like and a comment below. You can also subscribe if you haven't done so already. Like new subscribers. You can also follow me on Facebook, and you can become a Patreon for as little as $1 a month. Links are in the description as usual. Anyway, this is Astro 30 saying, see ya. Have a great day.